Hello guys, as you know, I am trying to learn integral and I really love this topic. This is my teacher's note and I will review all of those notes and then do some exercises from the book. So antiderivative, the indefinite integral. So, okay, antiderivative of indefinite integral. So we have notes here. Okay, f of x dx, the derivative of the, so we have reviewed those ones, but I will do all of them again. We have also, we have substitution. Okay, I want to start again, even though we did so many progress yesterday. Antiderivative to the indefinite integral. So fx dx equals to fx plus c. Okay, the derivative of dx equals to x plus c. The derivative of dx equals to x plus c. Example, let's do this with examples. 60x equals to 6x plus c, by the way, plus c, or the reverse. Okay, x to the power of 60x equals to x to the power of 7 over 7 plus c. Okay, sine x, derivative of sine x will be, okay, we are just talking about here derivative of sine x is cosine x, but integral of cosine x equals to what? Sine x plus c, because the derivative of cosine x equals to negative sine x, and the derivative of sine x dx will be what? Negative cosine x plus c, because a derivative of cosine equals to negative sine. Okay, derivative of negative cosine x equals to sine negative sine x cosine x plus c. Okay, it will be sine x, so that's why ln x, the derivative of ln x equals to 1 over x. So it means that the integral of 1 over x will be ln x, but like this, ln x plus c. I always forget plus c. Okay, that's over there. Okay, I only think that I don't know here, and I remembered the derivative of ln x equals to 1 over x, and the derivative of ln f of x equals to derivative of f of x, derivative of f of x over f of x, but I don't know why, but I just remember this rule, so let's learn it. DeepSeek. Okay, y derivative, not derivative, but yeah, derivative oh my gosh, of okay, ln x ln f, oh my gosh, f of x equals to f derivative of x over f, why it's not working, I don't know, fx. Great question. This is a direct application of the chain rule. Let y equals to ln f of x. Set u equals to f of x, so ln u. Differentiate. Okay. Oh my gosh. I don't know why. What is this? I did not understand. Explain simply. In a simple way. Okay, in a simple way. But anyways. Okay, ln derivative of ln anything equals to 1 over that thing, fx, because inside change it. Okay, so we know that the derivative of 1 over x dx will be ln x plus c. Okay, then a derivative of ex, sorry, not derivative but integral, and ex to the ex, derivative of ex equals to e to the power of x. So integral is the same, it never changes. So if we have a constant like c times fx dx, so we can write this constant like s c times f integral of f of x dx. Okay, for example, that is our example, like 5x squared plus 35x dx. It will be 5 because that's constant, x squared plus 7x dx. Then integral is 5 times x to the power of 3 over 3, 7x squared over 2 plus c, like this. Yes, that's true. That's 3 by the way. Okay, x squared, that is our sum rule. We have talked about it in the last lesson, but anyways, I will review it again. Dx, that will be so x squared, integral of x squared dx plus 7x dx. Well, x squared, x to the power of 3 over 3 plus 7x squared over 2. Good job. Sine ax plus b will be, okay, that's, that part is really complicated for me, but let's try to learn it. Sine ax plus b, for example, sine 7x plus 10, it will be integral, integral, or what? So in derivative, how was it? Derivative of cosine was negative sine, derivative of sine was just cosine. Okay, the derivative of, I guess, sine is cosine 7x plus 10. Yes, we are trying to find the derivative of this one. Okay, the derivative of this one, firstly, according to the chain rule, it will be what? Sine will be cosine 7x plus 10, then we will multiply it by just this one. So we, in derivative, we need to pay attention to the overall thing, then that thing. The overall will be cosine 7x plus 10 remains the same, times the derivative of just 7x plus 10, and it will be times 7. And it will be 7 cosine 7x plus 10. What about the integral? Or yeah, integral or what? Yeah. What about integral? I think the problems about an integral will be on the book, other book. But let's try to do this one. X squared plus 4x minus 3 dx. So according to our sum rule, I want to write this such as, okay, wait a second, I just don't want to see a solution. X squared dx plus 4x dx minus 3 dx. It will be x to the power of 3 over 3, 4x squared over 2, it will be 2x squared plus 3x plus c. I think it will be like this, isn't it? Yes. Oh, yeah, that must be minus. Okay, well, let's go to this one. So integral of x minus 1 over x squared plus 6x minus 9 dx. Okay, 9 dx. We will write this like x 1 over 3 minus x to the power of negative 2 plus 6x minus 9 dx. And it will be like x to the power of 1 over 3 dx minus integral of x to the power of negative 2 dx plus integral of 6x dx minus 9 integral of 9 dx. It will be what? 1 over 3 plus 1 will be 3 over 4. Okay, it will be like, let's write it simply, x to the power of 4 over 3 minus x to the power of negative 1 negative 2 plus 1, like, okay, negative 1 plus 6x squared over 2 minus 9x plus c. And it will be like 3 4 plus 1 over x plus 3x squared minus 9x plus c. Let's check. 4 3, yes. Okay, that's true. 1 over x, 3x squared minus, okay, good job. Let's try to do this one. C sine, the integral of sine 4x plus e to the power of 7x minus 1 over cosine square x dx. Oh my gosh. Okay, we will write this like integral of sine 4x plus integral of 4x dx plus integral of e to the power of 7x dx plus minus 1 over cosine square x dx. It will be like what? Okay, sine 4x. This is our equation. Sine will be what? Negative cosine. Negative 1 over 4 cosine 4x. Yes, sine will be told that sine will be always negative, yeah, but cosine will be always positive in integrals, plus e to the power of 7x. I don't know how it can be like e to the power of x is e to the power of x, but what about this one? 7 times x. I think it will remain the same, or what? 7 e to the power of 7x, I guess, minus 1 over cosine. Cosine will be always positive, and it will be integral of this one, it will be 10x. I don't know that exactly. Let's check it. Oh my gosh. So this is true. This part is true. Cosine 4x true, but this is not true, because e to the power of x, okay, it will be always like, if that is e to the power of, it must be, because it is integral, it must be always like over 7. I will remember it. Minus tangent x plus c. Okay, I forgot c again. Let's try to do this one. Integral of x plus sine x over 5 dx. Okay, it will be like what? 1 over 5 times, because constant can be out of the integral, so that's why 1 over 5 times x plus sine x dx. 1 over 5 times x will be what? X squared over 2 plus sine will be what? Negative cosine x, and it will be x squared over 10 minus cosine x over 5 plus c. 1 over 5. Yeah, true. So let's try to do this one. Integral of minus cosine x over 3 dx. It will be what? 1 over 3 times integral of x to the under root of, or what we thought, I don't know, dx. 1 over 3 x to the power of 1 over 2 minus cosine x dx. 1 over 3 times x to the power of 3 over 2 minus cosine will be what? Minus cosine will be always sine x dx, not dx, plus c. 1 over 3 times 3 times x cubic over 2 minus sine x over 3 plus c. I hope it's right. Let's see. 1 over 3 times, okay, 1 over 3 times what? This one minus sine x. Yeah, that's actually true, but my teacher remained it like this. Okay, my solution is correct. What about C? Okay, integral of cosine 2x over cosine x minus sine x will be dx. Okay, cosine 2x equals to what? Cosine square x minus sine square x, or what? Let's remember this again. Cosine 2x equals to what? Cosine square x minus sine square x. Yes, that's what cosine square x minus through sine square x. Or I remember that cosine to x also equals to cosine. Firstly, give this one cosine square x minus 1, or 1 minus cosine square. No, sorry. That was like, firstly, this one gives cosine to x will be cosine x minus 2 sine square x. I don't know why, but I remember this like this. Maybe it's not right, but this one gives cosine to cosine square x minus, no, okay, I forget this one, but cosine to x, if this one will give, that will be 1 minus 2 sine square x, or if this one gives 2 cosine square x, I don't know, let's see. Yeah, 2 cosine square x minus 1 and 1 minus 2 sine square x. Okay. It's good that we remembered this one. So let's use this one, okay? Cosine to x equals to this one, and integral of cosine square x minus sine square x over cosine x minus sine x. Okay, it will be like dx, it will be cosine x minus sine x, cosine x plus sine x over cosine x minus sine x. Cancel them. That will be cosine x plus sine x dx. Cosine equals to what? Cosine is always positive, so sine x. Sine is negative in integrals, negative cosine x plus c. Is that true? Sine x minus cosine c. Yes, that's true. So example 3. The integral of 3x squared minus 8x plus 5 dx. So it will be like, again, our rule is that 3x squared dx minus integral of 8x dx plus integral of 5 dx. It will be what? So 3 times x cubic minus 4x squared plus 5x plus c. Is that true or what? So from 5x. And we also have points here. Okay, I remember that was a task. Okay, x cubic to 4x squared. So we had the points here, 1 and negative 4. To find c. So if we plug 1, that will be 1 minus 4 plus 5 plus c equals to negative 4. Negative 4 will be cancelled and c will be negative 6. Okay, and our function will be what? X cubic minus 4x squared plus 5x minus 6. Yeah, that is the favorite part of this lesson. We're just studying for like this. Is that 24 minutes? Are you kidding me? Oh my gosh, really? Anyways, substitution. I don't know how to say that. It's really hard. But let's see. Okay. We have integral x squared plus 6 to the power of 8, okay, times 2x dx. We need to think the derivative of each of them. So the derivative of 2x will be 2, so it won't do anything for us, but derivative of x squared plus 6 will be 2x. So this one is u, x squared plus 6 equals to u. Du will be what? Okay, du over dx is what? Du over dx is 2x. Du over dx is 2x. Yes, it means that derivative of u, du over dx equals to 2x. And what about du in here? It will be 2x times dx. But I have seen like in organic chemistry tutor like this, u equals to x squared plus 6, and du will be 2x, and du or 2x dx, and du over dx will be du over 2x. Or what? Du or du? Yeah. No, sorry. Du over, not du over dx. Just dx will be du over 2x or something like this. I don't know. Okay, how was it? That was on my phone. Let me check it. Okay, yeah, that here it is. So he has written like what? Now I'm checking it. For him, du over u equals to x squared plus 5. Du equals to 2x dx. Yeah, u equals to x squared plus 6 here. And du, derivative of this one equals to 2x dx. Okay, what about dx? Dx will be du over 2x. That's the same thing, okay? I can write either like this or like this, doesn't matter. But it means that it's more easier, like that's really more practical because we are trying to find everything. Du, dx, du over dx. Okay, anyways, I got a little bit confused because of those two methods, but anyways. So then we will substitute the values. X squared plus 6 will be what? U to the power of 8 times 2x. 2x is what? Du over dx times dx is what? Dx is what? 2x dx, sorry. 2x dx equals to, I didn't see this one. Equals to du, okay? So u to the power of 8, and the integral of this one will be u to the power of 9 over 9 du, and this will be plus c, isn't it? So u to the power of 9 will be what? U equals to x squared plus 6 to the power of 9 over 9 plus c. Yeah, so I just got confused a little bit because of that thing. Which one could be easier for me? Let me think about it. Firstly, we have what? We have this one, derivative of this one will be 2, derivative of this one will be 2x, so that is x squared plus 6. The derivative of du over dx will be 2x. So if we are trying to find du here, it will be 2x dx. Okay, let's substitute x squared plus 6 okay, that will be u to the power of 8 times 2x dx equals to what? Du here, du. And this will be u to the power of 8 will be u to the power of 9 over 9 plus c. U to the power of 9 equals to what? U to the power of 9 equals x squared plus 6 to the power of 9 over 9 plus c. Okay, I get it. Let's try to do this one. Integral of sine square x times cosine x dx. Okay, let me think about it. So derivative of sine square, sine square. Okay, derivative of cosine will be what? Just think about not square, but sine will be not derivative, but integral cosine. Okay, cosine square x. What about cosine negative sine? I don't know how to do this one actually. If we say sine, why did we do? Okay, why sine? If we say u equals to sine x, derivative of sine x will be cosine x. Okay. Okay, cosine x, and du will be cosine x dx. So derivative of that will be sine will be u squared, cosine x dx will be du. Okay, I get it, but if we did sine, cosine, okay, if we did this like cosine, what will be cosine x? Derivative of cosine will be negative sine x. So it will be negative sine x squared. Yes, okay, let's find du. It will be what? It will be negative sine x dx. Okay, we don't want something like this. Okay, wait a second. I will ask this question to my teacher. So why we don't do like this? Okay, it will be what? Sine square x will be sine square x times cosine x will be u dx, cosine x dx, sorry, cosine x dx. We don't have cosine x dx. Okay, that there is an error. So yeah. Okay, I want to remember this as a rule, that always take the power whose power is the highest will be the one that could be substituted. Okay, if we see this one, it could be probably like, I want to ask this to my teacher again, but let me ask it right now. Okay, I asked him, and I don't know if it's true, but that is my conclusion. Like, which one has the highest power? Could be u. So sine x will be u. A derivative of this one will be negative cosine x. Yeah, and du will be negative cosine x. Am I right? Okay, wait. Derivative, sorry, not integral, but just the derivative. Oh, I'm sorry. Derivative of this one will be cosine x, and du will be cosine x dx. Let's write this. Sine square x will remain what? Sine x equals to u to the power of 2 times cosine x. Cosine x dx is du, and it will be u to the power of 3 over 3 plus c, u equals to sine cubic x over 3 plus c. Is that true? Okay. Okay, well, let's try to do this one. 2x plus 3 over x squared plus 3x plus 1. So let's think about I've seen a video on YouTube on shorts like firstly check the denominator, and the derivative of the denominator will be 2x plus 3. Yes, 2x, and we will that will be, yeah, u will be here x squared plus 3x plus 1, and du over dx. So the derivative of this one will be 2x plus 3, and du will be 2x plus 3 dx. And let's substitute 2x plus 3 over x squared plus 3x plus 1. It is u to the power of 1 over 2, negative 1 over 2. Yeah. Oh, sorry, dx. We also have dx. Oh my god, I got really confused right now. Wait a second. 2x plus 3 is what? Du over dx, yeah. Du over dx. X squared plus 3x plus 1 is what? U to the power of negative 1 over 2. Dx is what? Oh my gosh, I got really confused right now. Wait a second. 2x plus 3 du over dx. 2x plus, okay. 2x plus 3 dx will be what? Du over what? X squared plus 3x plus 1. It will be u to the power of negative 1 over 2. And it will be what? U to, like du over, it will be what? Oh my gosh, I got really confused. Du, okay, no worries. It will be u to the power of negative 1 over, okay, I get it. 2x plus 3 dx, yeah. 2x plus 3 dx equals to du, okay. X squared plus 3x plus 1. Let's write this like x squared plus 3x plus 1. It equals to u to the power of 1 over 2, okay. And it equals to du times, but u to the power of negative 1 over 2 du, okay. So what is the integral of this one? It will be u to the power of negative 1 over 2. It will be u to the power of 1 over 2, and it will be 2u plus c. And it will be 2 times u equals to x squared 3x plus 1 plus c. I think it's like this. Yeah, exactly. Okay, I got really confused in this example, but we did a great job. But about, no, that is off topic. That was my question. So I did those things. It's really good. I finished that slide, and now I think it's time to do from the book, from that book. Okay, we were in here. I was in here, okay. Problem 8. Let's try to solve some problems. So 4 cosine 3x dx. It will be like what? That is our constant, yeah. So because that's our constant, we can write this as 4, I don't want to dislike this, but you will understand. 4 times cosine 3x dx. And according to the rule, 4 times cosine will be, for integrals, cosine is always positive. So cosine 3x, it will be, I didn't understand this rule last time, but I asked this to my teacher and he explained me like 1 over 3. Cosine is always positive, so it will be sine 3x dx, not dx, plus c. So 4 over 3 sine 3x plus c. Is that true? 4 over 3 sine 3x plus c. Okay, good job. What about this problem? So we have integral of 5 sine 2 theta d theta. Imagine this theta is x, okay? But theta is sounding really aesthetic. So 5 times integral of sine 2 theta d theta. It will be 5 times, we have 2, it will be what? 1 over 2. But sine is always negative. Integral of sine is always negative cosine, okay? Negative cosine 2 theta plus c. As a result, negative 5 over 2 cosine 2 theta plus c. Is that true? Negative 5 over 2 cosine 2 theta. Yeah, that's true. Let's do problem 9. That's really interesting for me, and that's really enjoyable to do integrals. Let's do 7 secant squared 4t dt. Okay. 7 times integral of secant squared dt 4t dt. Okay, 7 times secant is what? 1 over cosine square t, yeah? Or no, 1 over cosine secant, okay, 1 over cosine square 4t, like this. And it will be cosine, 1 over cosine is what? 10. 7 times tangent 40 times 40. Okay, oh my gosh, I got confused. Firstly we forgot that. Okay, we simplified it, and that is our integral, yeah? Cosine is always positive, so that's why it will be like cosine square will be what? 4 cosine square 4t. I don't know. Oh my gosh, I don't know. 28. Is that 28? Let's see. No. Oh my gosh. Oh, that was tangent. Yeah, you see that here. Okay, let me try this one again and again, because I confused myself a lot. So 7 times integral of secant squared 4t dt. 7 times secant is 1 over cosine square 4t times dt. Is that 4t? Okay, is that true? I just want to know that. 7 is 1 over 4. Actually, we are right, because 1 over 40, yeah? 1 over 40, and 7 times this one will be tangent 1 over 40 times no. Okay, let's check this one. It's on the table, actually. Let's check this one. Where's the table? 1 over secant, or just tangent is what? Secant square equals to 1 over a tan. Okay, 1 over a tan. Secant is 1 over a. Secant square. is 1 over a. Okay, 1 over a. So, but if I don't know this one, I could say that secant square ax dx is secant is 1 over cosine square ax dx. And yeah, this will be what? Tan ax dx. Like this. But 7. Where is my problem? Yeah, that's here. So 7 secant is what? Let's do like secant is 1 over cosine square, and 1 over cosine square equals to tangents in integrals. So tangent, but 1 over 4 tan 4t plus c. I get it. 7 over 4 tan 40 plus c. Okay, I get it. If I can do this one, it means that I really got it. Okay, if I don't, it means that I didn't. Cosecant square 2 theta dt. By the way, I didn't learn the things by heart. I just tried to learn and understand its logic. So cosecant is what? Cosecant. Secant is 1 over cosine square. Cosecant is 1 over sine square. Okay, it will be negative cot. Yes, I think that will be negative cot. 3 times 1 over 3, negative 1 over 3, negative 1 over 3, cot 2 theta plus c. Is that true? Yeah, good job. I really got it. So let's write this one. Okay, so 5e to the power of 3x dx. It will be, again, it will be like 5 times integral of e to the power of 3x dx. And it will be 5 times e to the power of 3x over 3 plus c. Is that true? And let's try to do this one, but that will be later. No, it's not true. Or it's true. 5 over 3 to the power of 3x plus c. Okay, good job. What about this one? Integral of 2 over 3 e to the power of 40 dt. Okay, let's simplify it. It will be 2 over 3 times integral of e to the power of negative 40. Yes, 40 dt. 2 over 3 times, it will be like what? Let's imagine e to the power of negative 40 plus 1t or plus t over negative 40 plus, not negative 4 plus negative 4, 40 plus 1. Actually, it must be like negative 40 plus 1, but negative 4, yeah, it must be like this as a rule. Negative 4 plus 1 plus c. Let's see, 2 over 3 times negative e to the power of negative 40 plus 1 plus c. Is that true? Negative 40 plus 1, yeah. So I think it's just simplified this one. I don't know that. Let's think about it. Try to think about it. It means that 2 over 3 times negative. Let's do this like negative 2 over 3 times e to the power of negative 40 times e over 3, and it will be 9 plus c. No, it's not. Okay, what is this? Negative 40, negative 1 over 4. Why? Okay. There's a rule in this one, and I don't know what is. Let me see this again with the e's. Where is my e? I just need e. I want e. Wait a second. But we had a rule here, like cosecant. Cosecant. Where is that? Sine. Yeah, that's over here. 7. Okay, that is just the rule that if we have like this, integral will be just divide by the power. Okay, let's try to do this one. Just zoom in, and I'm just gonna try to do this by myself again. Wait a second. Just delete. Okay, where is my original? No, oh, sorry. Yeah. Okay. In this one, 2 over 3 e to the power of 4t dt. Okay. 2 over 3 times integral of e to the power of negative 40, yes, dt. And 2 over 3 times e to the power of negative 4t, just over negative 4, okay, plus c, according to that rule. And we will do, and that will be negative 6 e to the power of negative 40 plus c. Is that true? Yeah, that's true, because that means that 1 over e to the 6 times e to the power of 40 plus c. That's true. Good job. I get it. Let's try to do problem 11. It will be like 3 over 5 dx. It's easy actually. 3 over 5x dx. So it means 3 over 5 times 1 over x dx, and it is equals to 3 over 5 times ln x plus c. Let's do this one and then check. M squared plus 1 over m. How can we write this one? How can we do this one? Yeah, we can use substitution, I think. For example, it will be derivative of the power will be what? 4m. Yeah, I think it's like this, because derivative of m will be nothing for us, dm. So our du is 2m squared plus 1 du over dm will be 4m. Du will be 4m dm. And 2m squared plus 1 equals to u. Okay, du here. 2m squared plus 1 du, 2m squared plus 1, 2m squared plus 1 equals to u over, is that true? Wait a second, 2m squared plus 1 equals to u, du, yeah, okay, dm, sorry, dm, that is m, okay, our u is 2m squared plus 1. Derivative of the dm, du over dm, derivative of this one will be 4m, okay? What about du? Not du actually here, that will be dm, but okay, 4m dm will be what? But that's the rule. Oh my gosh, oh my gosh, oh my gosh. Okay, 4mdm, 4mdm. Hmm, 2m squared plus 1 is u over m, 1 over m, or we just can write 2m. Okay, I think we can do this without substitution, because if we write this one 2m squared over m dm plus, because I got confused, 1 over m dm, yes, imagine that that is dm, it's x 1 over x, so it will be like 2m dm plus 1 over m dm, so 2m dm 2x will be 2 m squared over m 2, okay, plus 1 over m equals to ln m plus c, and it will be m squared plus ln m plus c. Let's check this one. Three over 5, it's 3 by the way, 3 over 5 ln x, yes, that's true. What about this one? M squared plus ln m plus c. Good job, really good job. Further problems on standard integrals. Problems 1 to 11 determine indefinite integrals. So it means that we are finishing, yeah. Yes, it means that we are finishing, yeah. Actually, we are finishing. Let's do those problems here. Derivative of 4x. It will be 4x plus c for a. For a, let's say. For a. What about b? 7x. Not derivative, pardon me. That will be an integral of. So it will be 7 over 2x squared plus c. Is that true? For x, c, and b, 7 over. Yes, exactly. What about this one? For the second one, that will be 2 over 5x squared dx. It will be 2 over 5 x cubed times x cubic over 3 plus c, and it will be what? 15 to x cubic plus c. What about this one? This one will be what? 5 over 6 x cubic dx. It will be 5 over 6 x to the power of 4 over 4. It will be 5x to the power plus c, 5a plus c, and it will be 24, 5x to the power of 4 plus c. Let's check. Exactly, and 5, exactly, good job. Let's do this one. 3 x squared minus 5x over x dx. It will be what? 3x minus 5 dx. It will be 3x squared over 2 minus 5x plus c. What about the other one? 2 plus theta d theta. It will be, we can simplify it like theta squared plus, I write it this by the way directly, 2 theta. Let's do it like theta squared d theta plus 2 theta, not 4 theta, d theta plus 4 integral of 4 d theta. It will be theta squared over 3 plus 4 theta, 2 theta squared, yes, plus 4 theta plus c. Let's check. 3 over 3x squared minus 5x plus c, 4 theta, this one, and this one. That's true. Good job. So I got it. I really got it. 4 over 3x squared dx. It will be 4 over 3 times integral of x to the power of negative 2 dx. It will be 4 over 3 times x to the power of negative 1 over negative 1. It will be negative 4 over 3 x plus c plus c plus c. What about other one? 3 over 4 x to the power of this one. It will be 3 over 4 times integral of x to the power of negative 4 dx. It will be 3 over 4 times x to the power of negative 3 over negative 3 plus c. It will be what? Negatives will cancel. Negative 1 over 3, negative 1 over 4 x cubic plus c. Is that true? Negative 4 over 3 x plus c and negative 1 over 4 x. Yeah, exactly. Good job. So let's do another one. 2 times integral of x cubic dx. Okay, it's so good. It means that 2 times x to the power of 3 over 2 dx, and it will be 2 times four I think it's correct. And what about this one? Is that true? Let's check here. 4 over 5 x to the power of 5. Yes, that's true. What about this one? What about this one? Oh, yeah. Integral of, let's do like this. 1 over 4 times x to the power of 5 dx. 1 over 4 times x to the power of 5 over 4 dx. It will be 1 over 4 times x to the power of 9 over 4. 9 over 4 over 9 over 4 plus c. It will be like 4 times 9, 4 x Is that true? I don't know if it's true or not. Is that true? Let's check it. 1 over 4, what's the next one? 1 over 9. Okay, it's right. It's not right. I made a mistake here. In this part, it will be what? Okay. That part is true, but 1 over 4 times 9 over 4 of what? Okay. That must be like the same. Okay, 9 over 4, and it will be wait, just wait. 4 1 over 9, 1 over 9, and 1 over 9. Yes, now it's true. Is that? Yeah, that's true right now. Let's do 6. I'll try to do each of them with different colors, so it can be a little bit good and fun. T to the power of 3 dt. So it is what? Negative 5 times integral of t to the power of negative 3 over 2 dt. Okay, so it will be negative 5 times negative 3 over 2 plus 1 plus 2. It will be negative 1 over 2. Yes, negative t to the power of negative 1 over 2. And is that negative? Yeah, negative 1 over 2 plus c. Negative 5 times that will be positive 10 times 10 over t plus c. Is that true? I don't know. Is that true? Yes, that's true. Yeah. So what about this one? What about b? Integral of 3 over 7 times this one dx. Okay, it will be like what? It will be like 3 times 3 over 7 times integral of x to the power of negative 4 over 5 dx, and it will be what? 3 over 7 times negative 4 over 5 plus 1 over 5, x to the power of 1 over 5 and 1 over 5 plus c, and 3 over 7. It will be 5. Okay, 15 over 7 times x to the power of plus c. Is that true? Where is this one? 3 over this one. Yeah, exactly the same. Look, good job. What about sine and cosine? Okay, actually the most interesting ones are sine and cosine ones, but I struggled a lot last time with them, but I really like them right now. 3 cosine 2x dx, 3 times, let's do like this, 3 times cosine 2x dx, and it will be 3 times cosine, no, the first one, cosine is always positive, so that's why 1 over 2 times cosine becomes sine 2x plus c, and our final result like this. Is that true? I don't know, but oh my gosh, 300, page what? Page sorter. Yes, I was there. Okay. Where I was here. Yeah, I was there. And 3 sine, no, 7 sine 3 theta d theta. 7 times integral of sine 3 theta d theta. 7 times sine is always negative. Integral of sine is always negative, cosine is always positive, and 3 theta will be 1 over 3 cosine 3 theta plus c. And finally, negative 7 over 3 cosine 3 theta plus c. Let's check them. This one is 3 over 2 sine 2x plus c, and this one is negative 7 over 3 theta. Yes, true and good. Let's do them. They're really hard ones. 3 over 4 secant square 3x dx, and let's write this one. Is that enough for us? No, it's enough. Yeah. And 2 cosecant square 4 theta d theta. Okay, 3 over 4 times secant square 3x dx. 3 over 4 times secant is what? 1? No, secant square is what? Secant is what? Secant is 1 over cosine, yes. And 1 over cosine is 1 over cosine square, and 1 over integral of 1 over cosine square is cosine 1 over cosine square, okay? And that will be 1 over 3 times tan 3x plus 3c, pardon me, 1 over 4 times tan 3x plus c. And what about this one? 2 times cosecant. Okay, secant is 1 over cosine, cosecant is 1 over sine square, yes, 1 over sine square. Sine is always negative, so negative 1 over 4, and that will be cot, okay, cot 4 theta plus c, and it will be negative 1 over 2 cot 4 theta plus c. 4 theta plus c, yeah. Let's check them. 1 over 4 tan 3x plus c, like this, and negative 1 over 2 cot 4 theta plus c. Good job. Let's do 9. 5 times integral of cotangent 2t times, oh my gosh, cosecant, oh my gosh, 2t times dt. Okay, we need to simplify it because cotangent 5 times, I think that we should write this like cot is cosine 2t over sine, no, yeah, sine 2t times cosecant is secant is 1 over cosine, and cosecant is 1 over sine square. 1 over sine square 2t, isn't it? Cosecant is what? Cosecant is 1. Cosecant is cot. Okay, oh my gosh. Yeah, cosecant is, oh my gosh, I got confused. Okay, cot remains same, okay. Cot 2t times cosecant is what? Cosecant. Okay, secant is 1 over cosine, and it gives us tan, but cosecant 1 over sine square. 1 over sine square gives us what? 1 over sine square gives us cot t 2t, cot 2t, and dt. And I think it will be 5 times. I'm not sure. Cot square 2t dt. And what is the integral of cotangent square? Okay, cotangent is what? I'm thinking about it, but I don't know how to do this one, okay? But I don't want to give up that, okay? I don't want to give up. It's getting harder right now after 9. Okay, cot is cot t or cosecant. Okay, now I got really confused, by the way. Cot 2t times cosecant 2t. But I made a mistake here, I think, because let's do this like what? If we don't simplify it, I made a mistake, okay. If we don't simplify it, cotangent is what? Cosine 2t over sine 2t times cosecant 2t. Secant is what? Oh my gosh. Secant is 1 over cosine 1 over sine square 2t dt. Okay, it will be what? 5 times, I am not sure, but cosine 2t over sine 2t sine square 2t. What's the point? I don't know. Let's check it. Oh my gosh, cosecant. I am gonna ask this to my teacher because it's really hard. Oh my gosh. I am gonna ask it, yeah. What about this one? 4 over 3. 4 over 3 secant 40 times tan 40 dt. Okay, I was really confident, but now oh my gosh, secant 40 times tan 40 dt. Okay, 4 over 3 times secant is what? Secant is what? Secant is what? Think about it. Because I'm really tired now, I cannot think, but okay, tan is sine 40. Okay, sine 40 over cosine 40 times secant is 1 over cosine square. Yeah, secant is what? I think 1 over secant is, oh my gosh, I cannot think right now. Okay, let's think it just simply. But secant, oh my gosh. Let's check this table. Secant square times tan square is Okay, it is formula, but I don't want to learn it. I don't fucking want to learn it. Oh my gosh. Okay, I can find its way, but maybe I cannot. I don't know that exactly. But let's simplify it. Second is what? Second. Let's ask this to the GPT. Okay, what is secant x equals to what? Secant. Cosecant, not secant. 1 over cosine x. Okay, 1 over cosine 4t dt. And this one will be 4 over 3 times sine dt, sine 4t over cosine square 4t dt. Okay, now it's clear that sine 4t is sine is negative 1 over 4 times wait a second, times sine is cosine, okay, 4t times, what about cosine? Cosecant. Cosecant is 1 over cosecant. It is 1 over cosecant, okay? 1 over cosecant, cosine square. 1 over cosine is tan 4t. But 1 over 4 tan 4t. Okay, they will cancel. Negative 4 over 3 cosine 4t times tan 4t plus c, and it is equals to what? Negative 4 over 3 cosine 4t times sine 4t over cosine 4t plus c. Cosine cancelled. Negative 4 over 3 times sine 4t plus c. I hope it's right. Oh my god, it's not right. Why? Why it's not right? Okay, I will ask this to my teacher. Why it's not true? Okay. Let me write this. Let me ask this to my teacher right now. Why? I don't know. I didn't understand. I'm gonna ask it to my teacher. Wait a second. I'm asking this one. Okay, we have a problem in those two equations. I know that that is a formula, but I don't want to learn that formula. I just want to get its logic. So that's why I think The ones I couldn't do are essential, and I think maybe I can do that lessons part 3. But let's try to do, I asked that one, and I will ask this one to my teacher, but now firstly that B is really interesting for me. I was thinking that it's correct, but it's not correct actually. Okay, anyways, just try to do 10. Okay, integral of 3/4 times e to x dx. So it's easy. Integral of e to the power of 2x dx, and it will be 3/4 e to the power of 2x over 2 plus c, and it will be 3/8 e e to the power of 2x plus c. Is that true? Let's check later. And what about this one? 2/3 times integral of dx over e to the power of 5x. It will be like what? It will be, my teacher answered me. Okay, let me see. What is this? Wait a second. Okay, he's not available, so he will answer tomorrow. But anyways, it will be 2/3 times integral of e to the power of -5x dx. 2/3 times e to the power of -5x over 5, -5x over what? -5, okay? And it will be like 2 over plus c, by the way, plus c. And it will be like 2/3 times -2/3. Let's do times e to the power of -5 will be 5, -5 times e to the power of 5x plus c. And is that -2/15 times e to the power of -5x times e to the power of -5x plus c. Is that true? Let's check this one firstly. 3/8 e to the power of 2x plus c. It's true. Okay, what about this one? Exactly, that's true. Good job. What about this one? Integral of 2/3 dx. It's easy actually, because 2/3 times the integral of 1/x, and it will be 1/x dx, and it will be 2/3 times ln x plus c. What about this one? U square minus 1 over u du. Okay, I can apply substitution here. U square minus 1, let's do like x, okay, because I will say that du, okay, it will be hard for me. X squared minus 1, so u is x squared minus 1 du over dx equals to 2x, and du equals to 2x dx. Okay, x squared minus 1 will be what? Okay, sorry. Okay, so x squared minus 1 derivative of x equals to 1. Okay, there will be no meaning. X squared minus 1 over x. Okay, we can make it like, okay, if it doesn't work, it means that we should try something really different and easy. Okay, I think that we can write this like x squared over x. It will be x dx minus 1 derivative of, not derivative, integral of 1 over x dx, and it will be x squared over 2 plus ln x plus c, like this, I think. Let me see. Where's that question? Where's that? Yeah, that's here. Why I have problem with that science? Yeah, but solution's true. Okay, just just one thing. Okay, yeah, guys, my teacher explained it to me, and I just wanna finish them and then do them. Okay, let's do this one. 2 plus 3x squared, no, 3x squared over this one dx. How can we do this one? Okay, I have an idea. I think we can use substitution here. 3x plus 2 squared over x to the power of 1 over 2, yeah. And what? And what? And what? And what? And what? And what? Okay, okay. What is the derivative of this one? X to the power of 1 over 2 will be what? 1 over 2 over minus, okay, derivative of 3x plus 2 will be not this one. Okay, u is x 1 over 2 minus 1, yeah, so it will be negative 1 over 2, negative 1 over 2, negative 1 over 2, negative 1 over 2, negative 1 over 2. Okay, negative, I really forgot how to do derivative. Oh my gosh. Oh my gosh. Oh my gosh. Oh my gosh. Okay, just simply x to the power of 5. What is this? 5x to the power of 4. Yes. So 1 over 2 minus 1. 1 over 2 times 1 over 2 minus 1. Negative 1 over 2. Yeah. Okay, I took a little bit short break. Okay, because my brain is not braining. So it will be like what? We said that x to the power of 1 over 2 is our u, and our du will be 1 over 2 x to the power of negative 1 over 2, and it will be 1 over 2, okay, times like this, because if I didn't write like this I would definitely forget it. Okay, that is. And what about du over dx? Pardon me. And du will be what? Dx over 2 times square root of x. I hope it's right. I hope it is right. So 3x 2 plus 3x dx 3x plus 2, okay, dx, we have dx, 3x plus 2 x to the power of 1 over 2. Oh my gosh, I got really confused because what? Because okay, how can I do this in another way? because it doesn't work. Okay, it doesn't work right now. It doesn't work right now. I should try another method for this question. Let's say that 9x squared plus 12x plus 4 times x to the power of negative 1 over 2. Okay. I was trying to do this one, but I don't know if it's true or not. That's the worst part of it. But anyways. So 12x to the x to the power of 3 over 2 over 3 over 2 plus 4 times x to the power of 1 over 2 plus 1 with 1 over 2, okay, over 1 over 2 plus c. Do. Okay, 18 over 5 times x to the 5 plus 24 divided by 3, 8 x cubic 8 x plus c. I could be crazy if it's not true, but it is. It's true. Yeah, I'm so happy. I'm really happy for that. Oh my gosh. It looks like a genius work, really. Okay, I did a great job. What about this one? What about this one? Let's say I'll ask this to my teacher. Okay, let's do this question. Okay, 1 over t plus 2t squared dt. Okay, so now we will do what? We will do what? 1 over 2. Okay, let's just simplify it. Okay, 1. No, just, it is just a simple question, okay? Just do t 1 plus 2t squared dt, okay? 1 plus 2t squared dt. No, 2t squared like this, okay? dt, okay? And it will be 4t squared plus 4t plus 1 over t dt. Okay, and it will be like 4t plus 4 4t dt plus 4 dt plus 1 over t dt. 4t will be t squared, but what t squared? 2t squared plus 4t plus ln t plus c. Let's see. Is that true? No, it is not true. Why? Why it's not true? But my brain is not really working right now, and I am incredibly tired. So, how can I do this one? And otherwise, I don't know. I don't really know. So let's mark those questions because I cannot do them right now. I'm really tired. But we did a really good job and I appreciate my work for today. And that's it. And next lesson I will learn wait a second. I will learn definite integrals. Like they have borders as you can see, and I'm really excited about it. So that's it. Have a nice day and night night.